Alright, hi, welcome back to another video and time to pick our problem. Let's do cut the sticks. How hard can this one be? Alright, so you're given a number of sticks and you cut the sticks into smaller sticks until you have no sticks. And at each iteration you will determine the length of the shorter stick, cut that length from each of the longer sticks, and then discard all the pieces of the shortest lengths. When all the remaining sticks are the same length, they cannot be shortened to discard them. Print the number of sticks that are left before each iteration. So the return is this is a hard problem. The return output is an integer array. The first line is an integer, okay. So let's get a sample input. So 1, 2, 3, 4, 3, 3, 2, 1. So at first there are eight sticks, and then 6 sticks, and then 4 sticks, and then 1 stick. Oh, okay, so you basically just take the lowest number out of the array each time. So I guess I'll make a while loop. So while so n equals r len r, while n is greater than 0. Okay, well n is, so we also need like a final answer, so that will be short count equals 0. Oh no, it's an array, so short count will be an empty array, short count, and then it will return that array at the end. So while n is greater than 0, because once there's 0 there's no more sticks to cut, what I'm thinking is this is probably ineffective, but we make a function to find the smallest number in the array, and then after we have the smallest number, we go through the entire array again and we see how many there are of that smallest, and then we add that, so smallest count equals 0. And then so for x in range 0, len of r, oops. Oh, because we also have to build a new array. Okay, so new r, there's definitely a more effective way. So for x in range 0 until the length of the array, it's going to, oh no, small count needs to be a big number. So for x in range 0 len r, if r x, so if the index corresponding to x, so it starts at 0 and goes towards the whole length, so everything will get counted smaller than smallest count, and smallest count will get replaced by the index of that array, so that will give us the smallest number. Then we're going to go for the whole thing. I think new r needs to be outside, because holy cow, I'm really confused on how I'm going to reference the new array. This is how we're going to reference the array with the shortest, or with the smallest numbers cut out. So for x in range, go at it again. If our x equals smallest count, Smallest num. Okay, this is really bad practice how I'm naming these variables. Then plus equals 1. Then at the end, new are, no, short counts dot append. So we have all the logic there. The one thing we're missing is how we're going to get the new array. But if we had that, then I think this code should work. So we have our new array, else, new array. Oh, okay, actually, how to take out Python take away integer from integer array. So there has to be a takeaway function. So I don't even think we need that new array variable. Yeah, there's dot remove. Okay, so r equals dot remove rx dot remove x. Oh, it says remove the first occurrence of 2. Okay, so you do it not by the index, but by the value of the variable, which I feel is really weird. It should be by the index. So let's run the code now. And compilation error, of course. List index out of range. Oh, because it removes it. Yeah, because this is going off the original one. Because this triggers, right? And then this runs a certain amount of times. Okay. Maybe we can do some sort of if statement to check if that index exists. Check if Rx out of range. Okay, so right, so all of this needs to go into another if loop. So if x is greater than the length of the array, else break. Okay, maybe this will work. Okay, maybe we did have to put in that equal sign. Huh, this is weird. It should not be compiling that long. Your code exceeded the time limit. Yeah, no duh. Why is this code taking so long? That's really... Oh, it's breaking, so it's not able... So this whole... Instead of break, how do I just skip it? Oh, continue. Okay. I remember that function from a long, long time ago. Alright, this should work. Oh, whatever. Okay. Okay, so oh no, because then it will run. Yeah, right. Because every time it's removing that, but then the list is shorter. Because let's say we made the new one, right? So the new one. Oh, okay. I think I have the logic now. We make the new array, and then we wipe it blank, but we set the old one to the new one at the end. That way we don't have to worry about our list index going out of range. So array equals new r. And then instead of this, we're just going to do an if, and then we're going to do an else statement, else new array dot append, and then we're going to do r of x. Okay, so I'm pretty confident in this code, and it should at least compile at a bare minimum. If it doesn't, I'm incredibly confused because, yeah, I get it. This is kind of an ineffective code. Okay. Why does this code have a timeout error? Wait, no, but len of r is decreasing. For x in range len over r. Oh, okay, right. We can just use the min function. So smallest count equals min array. And that just saved the whole for loop. Huh? Right, at the end it's empty. So while r okay, at least we're printing the correct number now. So smallest count. Right, so this is how many of the smallest number there are. So if okay, so let's use a r.count function instead. So smallest sum equals r.count and then smallest count. Wow, this is way more effective. Hmm. Okay, so r dot count smallest short counts pen smallest num r expected and indented block. Yeah, sure. Equals smallest count dot remove r of x. So r dot remove r of x. Okay. Yeah, list index out of range. Does this work? Oh, I'm gonna get a timeout error. Yeah. Okay. I'm going to ask how to fix my for loop. How do I fix my for loop to avoid list index out of range? Oh, okay. It's for x in R colon. What does this mean though? I think it means for every. I think it's just the correct syntax of for every item. Okay, let's try this. So, it's not adding enough. So I'm going to understand why. So, smallest count equals the smallest in the array. Yeah. Oh, okay, let's try this. Len r minus small sum. Oops. No response. Okay. So we're trying to get the total number. Um, total equals len r. Right, because it's getting smaller. So, oh, that worked. Okay. So, let's go over our logic now. So, we take the smallest in the array. We didn't have to write a for loop. Then we take signed but never used. Can make this code way more effective. So we take the smallest and then we add the number of items in the list and then we remove all of the smallest items. So that gets rid of like the smallest sticks and we return. So it looked really hard and it was kind of difficult, but the logic wasn't actually that bad. It was fairly straightforward.